let's revisit Hooke's law. Hooke's law deals with the spring force. It says the force exerted by a spring is proportional to the distance the spring is stretched or compressed from its relaxed position. Or in other words, Fx is equal to minus Kx, where x is the displacement from the relaxed position and K is the constant of proportionality, which is the constant of the spring. For example, if this is our spring, if this is the relaxed position, this is the mass, now my force is equal to 0. Now at this position here, the spring is compressed. If I'm using this as the positive x direction, my x here is negative. My force is minus Kx is positive, meaning it's pointing in this direction like shown. That's my spring force. Now, if it is stretched instead like here, then my x is positive, then my force, because of the negative sign, is negative and is pointing in the direction shown here. That's my spring force. The key here, what are the forces acting on the mass as it is moving from this position to this position here? If we do a free body diagram, x, y, the forces acting on the mass are the gravitational force, due to the earth pulling down on it, the normal force due to the floor pushing up on it, and then in the horizontal direction, the spring force. The spring force is going to be either in the positive x direction or the negative x direction. If we don't have friction, that's all. So according to Newton's second law of motion, sum of all forces, in this case it's going to be the gravitational force plus the normal force plus the spring force is equal to ma. Since we have only acceleration along the x-axis, so I write this along the x-axis, Fg has a 0 component along the x, Fn 0 component along the x, Fs is going to be minus Kx, and that's equal to ma. That's the key. We have ma equals to minus Kx, or A equals minus Kx over m. That's the condition for simple harmonic motion, having A proportional to minus x.